Hey y'all. Today's objective is graphs of linear equations. Linear equations. A linear equation has two variables in separate terms with
Hi. Hi. Okay, I feel like such a bad student. I left my backpack in our room and we can't get them because there's classes going on.
Okay, so Wednesday?
Yes. Okay. I feel so bad. Ugh, I'm like forgetting everything.
Do you have those things? No problem. Okay, you there? Okay. An equation has two variables in separate terms with each variable to the first power. So if it has to the second power to the third power, anything other than the first power, then it's not going to be linear. And the graph is a line because the root word of linear is line. What I mean by two separate terms is the x and y, usually the x and y, have to be separated by a plus or a minus or an equal sign. So you wouldn't have 2xy. That is one term, so that would not be a linear equation. A linear equation would be 2x plus y. Notice how it has the plus in between the two terms. So that's what I mean by two variables in separate terms, this one. And the graph is a line. So example of linear equations. An example of linear equations could look like y equals x minus 1. Another example of a linear equation could be 3p plus 5q equals 16. Notice it has two variables and they are separated by a plus sign. Even though it's not x and y, there still are two variables. Or you could have s equals 4t. That is an example of a linear equation. You have two variables and they're separated by an equal sign and they're all to the first power. Examples of nonlinear would be like the Pythagorean theorem, a squared plus b squared equals c squared. First of all, you have three variables and they're to the second power, so that is not a linear equation. Another example could be rate equals distance times time. You can't have two variables with multiplication, so that would be a non-linear equation. Another example could be y equals x squared. Y equals x squared is non-linear because it has a power of 2. So here are just some examples of linear and non-linear. The solution to a linear equation is the ordered pair that's on the graph. Any point, I think I said that, any point that's on the graph, any of the points that make up the graph can be solutions to a linear equation. So you're going to have lots of solutions. All right, so let's do some examples. All right, example 1, copy this down or look at your outline. Graph the function y equals 3x plus 2. Y equals 3x2. I'm going to show you how to graph it. First thing we need to do is make a table. We've been making tables. This is not new to you. We've been making tables. And fill in, here are the domains we're going to use, -2, -1, 0, 1. I'm choosing these domains because I'm going to graph it. I don't want to choose any big number like 10 or 20 because I'm not going to graph 10 or 20. So I'm choosing very, very small numbers centered around the origin. And when you plug them in into x, then you can come out with your y. So -2 times 3 plus 2. So this is -4, -1, 2, and 5. Now, if you notice, these all increase by 1, and these all increase by 3, plus 3, plus 3, plus 3. Now, after you make a table, you're going to pick your points and plot them. So I have my points. Remember, these are ordered pairs. This is the point -2, -4. -1, -1. These are my points. These are my solutions. So I'm going to plot these points on my graph. -2, -4, -1, -1. Whoops, I'm sorry. I went up 2, sorry. -2, -4, -1, -1, 0, 2, and 1, 5. You should have dots. Now, I had to draw my coordinate plane. You have a coordinate plane on your paper, so your line might be straight. The last thing, we're going to connect the points. So I'm going to, I'm going to connect my points. I'm sorry, it should be a straight line. You can obviously tell mine is drawn. You're going to connect your points and make sure you put arrows. Arrows signify that your line continues. And now you have successfully graphed a function. To find more solutions, I think we need to find more solutions, you can do one or two things. You can use your table to find some more solutions, or you can look at your graph to find more solutions. If you want to use your table, then you would just keep going. 2, 3, or you can come here, -3, -4. It's up to you. Or you could use your graph and pick another point on your graph. Your graph might be easier to read since it's a better coordinate plane. I want to go over the domain and range real quick. The domain are the x values. So how far left does it go? And it goes all the way to -infinity. And how far right does it go? Well, this line has the arrow, so it's going to continue and continue. So it is all the way from -infinity to +infinity. Whoops. And then the range is going to be the same thing. It's going to continue to go down to -infinity all the way to +infinity. And we talked about that in class. So the domain and range would be all real numbers, -infinity to +infinity. And then, like I said, to find 4 more points, you would plug in. So you could plug in -3. And then if you plugged in -3, you would come out with is it 7? And that would be another solution to this linear equation. But you know how to plug in points, so I'm not going to show you how to do that. But you could also use your graph. Example 2. Oops, cut off, sorry. Example 2, we're going to graph this equation. The same steps apply. We're going to make a table. And in my table this time, because I have a 1/2, I'm going to use even numbers so I don't have to deal with a fraction or decimal. So I'm going to use -2, 0, 2, and 4. If you want to use -1 and 1, you're just going to have a decimal or a fraction in your answer. I plug that value in, and 1/2 times -2 is -1 plus 1 is 0. 0 is 1. If I plug in 2, half of 2 is 1. 1 plus 1 is 2. And then if I plug in 4, half of 4 is 2. 2 plus 1 is 3. Now that I have my ordered pairs, I'm going to plot them. -2, 0. 0, 1. 2, 2. And 4, 3. So this is going up by 1 every time. 1, 2, 3, 4. 1, 2, 3. Then I connect. You connect and you put arrows. So you can see my line. My domain is going to be all real numbers, and my range, again, is going to be all real numbers. Whenever you have a line that's just going to continue, you can pretty much say your domain and range are going to be all real numbers. Find 2 more solutions. Again, you could use the table. So you could extend your table to 5 and 6, or you can use the graph. So let me show you how to use the graph. I see that I have a point right here that is intersecting at 0, -2. -2, 0. And then I see right here, that point is going to be -4, -1, because it's going to go over 4 and down 1. Over here, I could pick another point on my table, and it would be 6 over 6, and it would be 1, 2, 3, 4, 6, 4. So that's how you use the graph to find more solutions. You find other points on the graph that are easy to read. There are lots of points on this graph. This line, these are solutions, are made up of tiny, tiny little dots. These are a bunch of points. But they're going to be fractions or decimals, so I'm just picking the whole numbers. All right, example 3. All right, graph this, but first we need to put it in function form. We've been practicing putting things in function form. I'm going to subtract my 2x from both sides, and I'm left with y equals negative 2x plus 3. Again, I want my x term to come first. Here's my function form. Now I can make my table. Since I don't have a fraction, I'm just going to use my normal negative 1, 0, 1, and 2. That's just always my go-to. I plug them into my equation. If you're not sure how I got those numbers, I took my input, I put it into the x, I substituted it in, and then I found my output. Notice these are increasing by 1, and these are decreasing by 2. Minus 2, minus 2, minus 2. So my line is going to look a little different. I plot my points. Negative 1, 5. So negative 1, 5. 0, 3. 1, 1. And 2, negative 1. I have plotted points, and so now I can connect them. And don't forget to include your arrows. So that is the graph of this equation. I have graphed an equation. What this means is these are all the solutions to my graph. Every point on here, not just the ones that are whole numbers, but every point on here is a solution to this graph. It could still be a decimal or a fraction. But this graph is a solution to the equation. These are all the ordered pairs that are solutions to my equation. And again, the domain and range are all reals, negative infinity to positive infinity, because the line keeps going and going. All right, some special cases. Whoops. So take a look at this. Some special cases. What if there's only one variable? We've been working everything with x and y. Well, what if there's only one variable? It's going to be a special case. If you only have x, let's say x is equal to some number. This is some number. Then this means every x value is going to be this number. For example, just example, let's say x is equal to 1. That means if we made a table, x is going to equal all the way down. X is always going to equal 1. No matter what numbers we put over here, x is going to equal 1. If x always equals 1, then that means we're always going to go over 1. No matter how high we go, or no matter how low we go, we're always going over 1x in the x direction, always over. And then if we connect these, we see it makes a vertical line. Oops. A vertical line. If you ever see x with a number, it's going to make a vertical line, whatever that number is. So if x was, this line is x equals 1. If x equals negative 5, then it would be a vertical line at x equals negative 5. Anytime you have x as a number, it's going to be a vertical line, and it would be this number and 0. Because if it's on the x-axis, that means the y is 0, because it doesn't go up or down. Now, the opposite is true for y equals a number. If y equals a number, you could probably guess it's going to be a horizontal line. That means all the y's are going to be this number. So this is going to be a horizontal line. Let's just, an example, let's say y is negative 2. That means no matter what your x value is, no matter if it's positive 10 or negative 10 or infinity, your y value is always negative 2, which means we go down negative 2. No matter what your x value is, your y value is always negative 2, and it creates a horizontal line. It creates a horizontal line, and it always passes through 0, we'll call this b. Whatever it is, it's always going to pass through 0b. Because it's not going to go left or right, it's going to go up or down, negative 2. Every time, negative 2. So those are the special cases if you only have one variable. If you have two variables, x and y, then your line is going to be slanted or diagonal. But if you only have one variable, it's either going to be a vertical line or it's going to be a horizontal line.